Hi, I'm Miss Johnson Alexander. This is Exercise Physiology Week 2. That's Chapter 2 in the book. And this lecture is going to be pretty short, foundational things. It's important that you understand Chapter 2 because it is the foundation for the course. Chapter 3 gets into bioenergetics. On page 23, there's a good picture of the cell, and you'll have an assignment in Week 3 to label and understand certain parts of the cell. In exercise physiology, we go subcellular, and that means we go under the cell. We go within the cell, find out what's called organelles, what they do, what their job is, what they're called. And we look at, in exercise physiology specifically, we look at how the body responds to exercise, and conversely how the body responds to lack of exercise. And it goes body system by body system, and what happens physiologically when exercise is present and when exercise is not present to either prevent disease or that facilitates the cause of disease. So that's what exercise physiology is about. We do, like I said, go subcellular, so there's a lot of terminology. If you're not familiar with that terminology, I suggest that you have a dictionary handy to look up words, or get an app or whatever you need to do and look up words that might not be in the glossary of the book so that you understand and comprehend better what's being said. Now, in Chapter 2, they talk about homeostasis and steady state. Homeostasis is the body maintaining a constant internal environment, and that environment is at rest when you are, and those are things like body temperature, hydration level, specifically water, oxygen levels, CO2 levels in the area of your gases. So those are some examples of homeostatic controls that have to be regulated, systems that have to be regulated. Also, hormones. Hormones play a huge role. Hormones are chemical messengers of the body, and if they are not being made, you have a problem. If they are being made in too much abundance, you have a problem. And if they're not being received. So if they're being made but they're not being received at their receptor sites, then a person will have a problem for one of those three reasons. So hormones play a huge role. They work in every body system. So what this book does is it gives you the foundation, Chapter 2 and 3, and then it goes into body systems and how exercise affects each body system. And then we get into how to do develop what's called an exercise prescription for someone, taking into consideration their health status. So what their heart condition, are they diabetic, their age, are they a smoker, the condition of their lungs, and we develop an exercise prescription. Now, we then look at disease processes and how they are, how exercise can prevent disease, and that's how the book works. That's the chapters it goes by. Of course, we look at nutrition. Nutrition is how we make our energy, and the body likes to use carbohydrates and break those down into glucose. That is what it likes on a daily basis for maintaining homeostasis, because it's easy to break down glucose into energy. It's harder and takes more energy to break down fats and fats for energy, even though we get more energy from fats per kilocal, but it takes a lot of energy to break down fats. And when you break down fats, they release a poisonous chemical called, poison to the body, called ketones. And the liver, that circulates in the bloodstream, and we have to excrete that through our kidneys. Sorry. Now, proteins, their job in the body is not so much energy production, it's healing, it's growth, maintenance, and repair. So those three things. So the book will follow that course. talk about nutrition, the foundation, then talk about body systems and nutrition, and then diseases and disease processes, and then how to write an exercise prescription as the professional. All right, now back to chapter 2. Homeostasis. I already discussed that, but steady state is when the body is usually when you're exercising, we use the term steady state. We try to keep things normal. For example, body or within a certain range. Now, normal body temperature for you it's going to be between 97 and average is 98.6 degrees Fahrenheit. But that's at rest. But when you're exercising, one of the byproducts of making energy is we let off heat. So just like a car engine lets off heat, and so we produce heat also. Obviously, you know that because you've exercised and you sweat, okay? Or you've gotten hotter. So we have to, our body temperature is going to go up. The thing is that it goes from our normal range, our normal body temperature, to we have to keep it between 100 and 101 degrees. So there's not very much room for increases in the body. When you get to 102, you're going into heat exhaustions, and above 104, you're going into heat stroke. Basically, you are cooking your internal organs, the brain being the most sensitive because it has the most water in it, and we just are evaporating that off, burning that off, causing damage to the brain, or effects to the brain and nervous system will show. You have things called negative feedback, goes into body control systems. Negative feedback, positive feedback. Negative means opposite, and positive means same. Positive feedback, the example is always childbirth, and I just went through that that feedback system. But the book simply explains those and gives you diagrams. Talks about gain of a control system. Once again, capability of the control system. This means that the control system with the large gain is more capable of correcting a disturbance. Pretty simple to understand there. Now, they give you examples. Talk about, body temperature is easy to understand. Blood glucose. They go into diabetes. They hit on diabetes a little bit. Diabetes, you have to understand that it's this simple definition. Diabetes is when the pancreas, which secretes insulin, okay? The pancreas is our organ. It's a organ that's used in digestion. It secretes bile for digestion, and it's also a gland because it secretes the hormone insulin. Insulin is needed to take glucose, which is also called sugar, into the cell. If we do not have glucose inside our cells, we cannot make energy. And that's what exercise is all about. If a person stops making energy, they're dead. Okay? So, energy production can only happen inside the cell. That's something called ATP. You might have been familiar with adenosine triphosphate. But that's one of the forms of energy that we make inside the cell. It's the most common form of energy that we make inside the cell. But if we don't have glucose inside the cell, we can't make energy. Okay? So, glucose circulating in our bloodstream, it's poisonous, is acidic to our blood vessels, meaning it erodes them. Once again, glucose circulating in our bloodstream is acidic and it erodes our blood vessels. So that's why people that are diabetic and are constantly having high blood sugar because they don't watch their diet, they don't do what they're supposed to do. That's why it leads to amputations, it leads to blindness, because those blood vessels that are feeding the arm or the leg or of course the eye, they're very small and can't take a lot of pressure, and definitely erosion. That's why those things happen, is because sugar is acidic to blood vessels. Now, back to the pancreas. the pancreas can get angry and stop secreting insulin. The pancreas can not secrete enough insulin to cover the food that the person eats. The pancreas can also, the body cells can also stop being receptive to the person's insulin. So they have to have insulin injected into them because their body is no longer receptive to the insulin that they produce. Now, exercise, however, it makes the blood cells more receptive to insulin. It makes them more accepting of insulin. And you might have heard of active transport and facilitated diffusion. Think of that. That's how sugar gets inside the cell. It takes somebody else, which is insulin, to get the sugar inside the cell, get the glucose inside the cell. Now, that's diabetes in a nutshell. Okay, type 1, you're born with the problem with your pancreas or your insulin. And type 2, you've eaten yourself into that situation. But those are the simple definitions. But that's what diabetes is. Whether you're born that way or not, it's an issue with insulin getting sugar inside the cell so the energy can be made. Now, normal blood sugar is 70 to 100. You need to remember that. Normal blood sugar is between 70 and 100. So when we say high, that could be 200, 300, 400. Highest I've heard is in the 800s. Then low blood sugar, your comas are going to come either way. Low blood sugar could be 30, 40, and that's called hypoglycemia. If you don't eat breakfast and eat a meal or whatnot and go throughout your day, you will become hypoglycemic, which means low blood sugar. Your liver gets you through the night of sleeping by releasing stored glucose into your bloodstream. But the brain cannot store glucose, so it has to have a steady supply. So when you wake up, your liver is pretty much tapped out of glucose. Okay, so then when you get dizzy in the middle of the day, cranky in the middle of the day, lethargic, that's due to your blood sugar being low and your liver doesn't have any more to draw from to put into circulation. Okay, so the brain, once again, though, cannot store it. The other muscles in your body, the muscles in your body can store glucose, but the brain cannot. It has to have a steady supply. And it gets it from your bloodstream. And so it has to have insulin produced, and it has to have glucose there to take into your brain cells. Now, talks about stress proteins and the regulation of cellular homeostasis. Cellular is inside the cell. That balance has to be maintained, meaning the cells have to have enough materials to repair themselves, enough protein. That's protein synthesis. Synthesis means make. So it has to regulate oxygen levels, CO2 levels, water levels, and how much of a material it needs to make proteins to do its job, whatever the job of that cell may be. So you can think of it as a construction site and making sure that you have enough hammers and nails and equipment and lumber and steel and everything you need inside that cell to build and make whatever you're supposed to be building and making. And that's pretty much it with chapter 2. It's homeostasis, steady state, and it introduces you a little bit to diabetes.